I'm Klaus Pontoppidan. I'll be your MC tonight. And we have a full program. So we're hoping that you're enjoying the refreshments. Those are kindly provided by Northrop Grumman, so thank you very much to Northrop Grumman. It's an exciting time as we're getting close to the call for proposals for Cycle 1 for the James Webb Space Telescope. This is our agenda tonight. First, we'll be hearing from Eric Smith from NASA headquarters, who will give us JWST status and updates from the project. Then we'll hear from Jane Rigby from Goddard, who will tell us about operations and launch preparations. We'll hear from Lou Strolger from Space Telescope Science Institute, who will tell us about the Cycle 1 call for proposals and the science timeline. You'll hear from me, who will be talking about crafting your proposal. And then finally, but not least, we'll hear from Katie Alatalo from Space Telescope, who will be telling us about the JWST Masterclass workshops. And we hope many of you will have an opportunity to attend those. So without further ado, we'll yield the floor to Eric Smith, please.
Great. Thanks, Klaus.
Thank you so much.
Okay, so as Klaus said, what I'll do today is give a little bit of review of what happened over the past year, talk about what to expect in the near-term future. But first off, I want to call your attention to the fact that this slide no longer has a computer-generated picture of the James Webb Space Telescope, but an actual picture of the James Webb Space Telescope.
Sounds kind of low, maybe.
Okay. How's that sound? Better? Maybe I'll just stand a little bit closer to the mic here. So yeah, so I could almost end my talk right there with that picture. This is, of course, the telescope out at the Northrop Grumman Space Park facility in Redondo Beach, and there are some very proud techs and engineers standing in front of the picture. So let's just recap what occurred in 2019. At the start of that year, we still had two pieces for the observatory, and the spacecraft element, which is the spacecraft bus that houses all the infrastructure supporting the observatory, and the sun shield, which we don't really need to explain to this crowd. That's the spacecraft element. It was going through its element level testing, going through the launch environments and thermal vacuum testing. And the big event for the year, which was pretty widely covered in certainly social media, and you probably heard in August, was when the science payload and the spacecraft element were mated. The whole time that was going on, up at the Space Telescope Science Institute, many rehearsals of the various stages of commissioning were occurring. So they're practicing things like the first burn that they have to do after launch, or doing wavefront sensing and control. They're rehearsing those all year long up there at the Institute. And importantly, with the stretch out we had last time, 2017, 2018 of the launch, they had the opportunity to enhance some of the tools that you all will be using, both to propose and to analyze data that come back from Webb. What I next want to do is show you a little movie that has been put together really for a lay audience, but this might be something you could use to, in your undergraduate classes, or if you're giving public talks, to introduce Webb telescope. So let's hope this runs and you can hear it.
This is your telescope, an engineering marvel, an exploration powerhouse. Use it to look back in time and explore the first galaxies that formed after the Big Bang. To peer into atmospheres of planets orbiting the stars. It's your eyepiece to the uncharted, unknown, and unimagined. This is the largest, most complex, and challenging space telescope ever constructed. It will change our understanding of the universe and our place in it. The James Webb Space Telescope. Equipped With the largest primary mirror ever to be flown in space at 6.5 meters, it's more than 6 times the size of the Hubble Space Telescope primary mirror. Webb's 4 cutting-edge infrared instruments and cameras operate at super cold temperatures colder than the surface of Pluto. Getting this cold is done with the help of the largest sun shield ever flown, a 5-layer, tennis court-sized sun shield that blocks heat from the sun, Earth, and moon. Webb will be the first telescope to detect light from the most distant galaxies in the universe. These first galaxies formed about 13.5 billion years ago, only 300 or so million years after the Big Bang. Webb carries advanced technologies to tackle some of the most fundamental questions about the universe. How did the first galaxies form and evolve? Are there chemical signatures of the building blocks of life on other worlds? Is our solar system unique? Launching such a large telescope into space is an incredible engineering challenge. Fully deployed, Webb is too large to fit inside any rocket fairing. Engineers designed it to be folded, like origami, to squeeze inside the European Space Agency's 5-meter diameter Ariane 5 rocket fairing. After launch, controllers on the ground deploy Webb remotely. Deployment is an intricate ballet. For nearly 3 weeks, controllers carefully unfold Webb. After this delicate dance, Webb's golden mirrors are precisely aligned using motors behind each hexagonal mirror segment, adjusting them to form one perfect mirror. Once the instruments are fully cooled, the exploration will begin. Webb is a technological challenge like no other, born of the efforts of thousands of people across the United States, Canada, and Europe. The James Webb Space Telescope is your telescope. Use it to explore, to challenge theories, to see sights yet unseen. It's yours to unfold the beauty and mystery in the universe and our place in it.
So the credit for that movie goes to Mike McClare, who's a videographer at Goddard, and that is, although he's collaborated with others to collect the footage and do some of the computer graphics, that's pretty much the work of just Mike who put that together. So we hope everyone likes that and uses it, and it will be on the JWST website. You can download it from there, and it's also going to go out in social media. So we have our exciting teaser movie there, where you saw the picture of the telescope fully assembled. Why don't we just launch it? Well, there's that little bit of testing we still have to do. So if we look in sort of very gross stages of the remaining things that have to be done before we're ready to use Webb, they're sort of the following big 6 stages. We're in the first hexagon up there, finishing that up. Right now they're folding the sun shield to get it ready for observatory level testing. And so soon we'll go into the observatory pre-environmental deployments. They'll do some deployments before getting it into its launch configuration. Then we will subject the observatory to the vibration and acoustic environments of launch. It never goes back in a thermal vacuum chamber at this point. Once it comes out of that environmental test, we have the biggest test of all is doing the deployments as we've done before, but now having simulated the launch. And then we finally get it ready for its voyage down to Kourou. So it looks like, just 6 things to go. Well, if we look just one level down at each of those steps, and I don't expect people to read everything in here, because in each of these boxes there are hundreds or thousands of steps to go still. You can see we're in that top row of things right now. We're in the sun shield folding. We've highlighted some boxes in blue. Those are generically called sort of first-time activities. It's the first time we'll be doing them either on the observatory assembled as a whole, or it's a unique activity we haven't done yet. The first of those blue boxes coming up there is a replacement of some electronic components that failed prior to spacecraft environmental testing. So we knew we've had to replace those. We have those replacement boxes in hand, and we'll be doing that towards the end of this month. And so that's a first-time activity for us, but then we move into the remaining hexagons there. And the other blue boxes aren't as unique as that replacement of hardware. We link up the cryocooler, and then we have some activities we perform with the observatory there in environments, even though both parts have gone through the environmental testing individually. So if we look at that in just the schedule format, now we've got things going across the top there in blue. Those are those activities listed out, and you can see the ground system is going along, and in about midway through the year, they will deliver their launch build. And importantly, now we can put the science community on this chart too, where we see the call coming out later this month. You'll hear more about that. The review of that call coming in the summertime. And so, as I've probably said before, we're just about done constructing the observatory, and pretty soon it's our job here to realize the promise of that. So speaking actually of what the community will be doing with it, if we look at those programs that are already scheduled for year one. So those are the guaranteed time observers and the early release science programs. And we parse it out into kind of broad themes, which I've labeled here first galaxies or exoplanets, stars and protoplanets. You can see the number of hours that the telescope is going to be doing in those areas. And this is before we get to the GEO call. So we have, although there's about 50% of it already devoted to these topics, we're excited to see what everyone is proposing once the call goes out. Just a couple of remarks on programmatics. So these are the things that we have to worry about at headquarters. Importantly, we did get our full funding for FY 2020, so we can thank the stakeholders throughout the rest of the government who have funded us as we needed. Some real insider baseball there. We get an annual audit from the GAO, and while they always note the schedule challenges, they did say that we were making significant progress, and importantly, they contained no recommendations for us at this time. And these are some of the major reviews coming up. There will be observatory environment, pre-environmental level reviews, the Cycle 1 TAC there, and then towards the end of the year, the actual operational readiness review for the program as a whole. So if I can leave you with some thoughts, we have a fully integrated observatory. We have the James Webb Space Telescope now. What we have to do is make sure that it works as planned. It meets all its requirements. That's a very important thing. We know from the tests that were done at Johnson Space Center of the telescope and science instruments, it's meeting all its requirements there. And then the test results that came from the spacecraft element testing also mean that this observatory will meet the needs of the community. The first call is coming out towards the end of this month, and although the schedule margin looks a little tight up there, we do remain within our budget, and we are planning to the March 2021 launch readiness date. And with that, I will turn it over to Jane, who will tell you more about what we're going to do with Webb once we launch it.
Thank you, Eric. So hi, I'm Jane Rigby. I'm the Operations Project Scientist for JWST. So Eric just told you about the status of the JWST hardware and the path to launch. And so this is the segue talk before we start really getting into the nitty-gritty about the Cycle 1 call for proposals. So I will talk about how we are getting to science operations, how we are planning to commission JWST to conduct science operations and to deliver high quality data to the scientific community, and importantly, how we are testing and rehearsing each one of those steps. So first of all, many of you know this stuff front and back, but I wanted to get everyone on the same page here that commissioning JWST is not like the simple in-orbit checkout period of a SMEX mission, right? We don't just launch it and then we start science. Commissioning is a complex 6-month-long process. And the reasons for that are as follows. First, as we know, JWST unfolds. And so each of those deployments has to happen in sequence. The tower extends, the sunshield deploys, the secondary mirror supports come down, and then wings that hold 6 of the 8 primary mirror segments swing out on hinges. JWST cools passively. There is time in the commissioning timeline. We are just waiting for the telescope to be cold enough that the science instruments don't saturate in their shortest exposures. JWST is also really thermally demanding. The telescope and the science instruments are operating at 40 to 50 K, and they're thermally isolated from a 300 Kelvin spacecraft. And so we have to check on orbit the thermal stability of the telescope as we slew around the sky. JWST, as you know, is segmented, and those 18 primary mirror segments aren't launched co-aligned. The initial alignment when we get up on orbit is off by millimeters, and so those need to be driven interferometrically to a precision of tens of nanometers. And that's not a fast process, I'll show you in a minute. And then finally, JWST has 4 science instruments with 17 observing templates, so we have a very complex and sophisticated science instrument suite. So the first month of commissioning is a very busy time. First, we launch on Ariane 5. 30 minutes after launch, we have this mid-course. We separate from the launch vehicle and the solar array deploys. All of that happens autonomously. Less than a day after launch, we have this critical mid-course correction. We fire our thrusters in order to send the spacecraft toward L2. So that is a lot of our work and rehearsals has been into getting that burn right, as Eric said. And then in the first 2 weeks after launch, JWST deploys. So we deploy the tower, the sunshield, the secondary mirror, and the wings of the primary mirror. Those major deployments are done about 2 weeks after launch, and then we start into the sort of excruciatingly slow raising of the mirrors up from their launch position to their readiness position. They need to move by 1.2 centimeters, and the actuators are very precise and slow. So that's the complexity. And let me show you what that looks like. So that's the first month of this timeline. That's the blue here is those deployments. And you can see the MCC-1A burn. The firing to get to L2 is right after is less than a day after launch. And then those deployments happen pretty rapidly. And then there's that gray period where it looks like we're not doing anything. We're cooling. Cool enough that we can turn on NIRCam at about, at this period, launch plus about 35 days, we turn on NIRCam, and now we start taking images that are not of one telescope, but of 18 different telescopes, right? Each mirror segment is giving us an image. So we have to take those 18 mirror segments and bring them together and then interferometrically align the telescope. So by about day 60, the telescope is aligned to NIRCam. We have 4 science instruments, and so then we have a process of aligning to the 3 near-infrared science instruments. We can't align to mirror yet because it's not cold enough yet, it's still cooling. So we've got a great, at this point of day 60, we have a great PSF, but just for NIRCam guaranteed. So we have to check that it's a good focus and a good point spread function for all 3 instruments first. And then once MIRI reaches its operating temperature, we do the process again, checking that all 4 science instruments are getting a good wavefront. So by day 120-something, the telescope is fully aligned. In that telescope commissioning period in orange, we've been using the science instruments all along. So we have been doing checkout of the science instruments. But in this green part, we are extensively commissioning the science instruments. In gray here is a thermal characterization where we go to a very hot attitude and then a very cold attitude, and so we're testing the thermal stability of the telescope. And then towards the end here, we're ready to evaluate each science instrument if it's ready for science. And so getting out of commissioning. So I should really stress for this audience that commissioning is not calibration. Commissioning determines that the observatory is working correctly and that the science instruments are calibratable. So the calibration program executes in cycle 1, and it's interspersed with the science program. Based on analysis of commissioning data, mode by mode, each science instrument mode will be approved as ready for science instruments. So science operations. So nominally, it's all done at 180 days. It is possible if we have problems with one mode that we would go into cycle 1 with that mode still being debugged, and then we would start science operations with the other modes. And then the early release observations will be taken near the end of commissioning, and they are designed to have wide public appeal and to demonstrate to the world and to the taxpayers who paid for it that JWST works. So those will be released in a major press conference toward the end of commissioning. So then we start cycle 1. 6 months after launch, commissioning is formally over. And science operations begin. And so the cycle 1 schedule intersperses all of our kinds of science observations, GO, GTO, ERS, as well as the calibration program. As much as we can, we've put the calibration programs in parallel, so they quietly happen while the primary science is executing. But things like flux calibration has to be done in prime. You need to go observe your flux calibration stars. And I should note that scheduling JWST is not a trivial thing. About a little less than 40% of the sky is observable to JWST at any one time, and then it seasonally cycles through to get full coverage throughout the year. When can you get your hands on JWST data? The commissioning data will go public at the end of commissioning. Now, most of that will be boring to you. It's wavefront stars, right? It's that process of alignment. But there will be some observations that have some scientific value. Also, the early release observation data will be public. The early release science programs, which are the ones that are designed to have high value science data for the community to demonstrate how JWST works, those are going to be scheduled in a front-loaded way toward the first halves of cycle 1. So the data will be public immediately, and the ERS teams are charged with providing high-level data products as soon as they're able. And I should note that some of the large GO and the large GO programs and some of the GTO programs will go public immediately. Now, because commissioning is not calibration, the first data that we get will not be perfectly calibrated. It will be calibrated based on ground test data, and then we will be updating those calibrations as we go deeper into cycle 1. And as you download the data, it just automatically reprocesses and gives you the best calibration. So that's just a thing to note that the data will get better just from executing the calibration program as we get deeper into cycle 1. So switching topics a little to JWST operations. So the Mission Operations Center is at the Space Telescope Science Institute. There is a backup mock located at Goddard in Greenbelt, Maryland. And as Eric introduced, we are about halfway through a really intensive set of rehearsals. We have been rehearsing every part of JWST's life. We rehearse launch and the mid-course correction. We rehearse the deployments and the telescope phasing. We rehearse the science instrument commissioning and then normal science operations. And we've been rehearsing those with an increasing number of anomalies as we, starting with just getting the team familiar with what success looks like and then pouring anomalies on them so that they're ready to deal with things that may happen in orbit. There were 9 rehearsals that we completed in 2019. Many of these were round the clock, multiple shifts. The bigger of these rehearsals involved more than 100 people from the following stakeholder groups. We have 14 rehearsals scheduled for 2020, so it'll be a really busy time for us. There's a lot of people burning the midnight oil, making sure that we know how to operate JWST. Also in 2020, we'll be doing 2 major tests that the MOC, the Mission Ops Center, can command the flight spacecraft. So we actually command the flight spacecraft from the MOC. And we've already tested that the MOC can communicate to NASA's communication systems, the Deep Space Network and TDRS. So to conclude, JWST will have far greater sensitivity than any previous observatory and far more sophisticated instrumentation, including spectroscopy that we've never had in space before. And we are doing the work now to be ready to deploy and commission JWST to characterize its on-orbit performance, to communicate that on-orbit performance back to the scientific community, and to execute science operations and get data out to the community. And we are extensively rehearsing every set of that process.
All right, so I'm Lou Strolger, and I'm going to give you an overview of the science timeline and what to expect for the soon-to-be-released Cycle 1 call for proposals. Here's that science timeline in graphical form. Cycle 1. So all of the JWST signposts are marked in blue on the bottom, starting with the call for proposals to be released on January 23rd. That proposal deadline will be May the 1st this year, and we expect to have the programs reviewed by ATTAC at the end of July and early August. The full announcements of those successful awarded programs will be in late August, and then we have a large period of time, which Klaus will probably talk about, in terms of validating and confirming those programs. What's interesting to note is how what else is happening at that same time frame. As you can see, this is a pretty crowded spring that we have coming up. For anyone who is interested in doing multi-wavelength work, you're going to be doing a lot of proposing. HST is there in the green. You can see Chandra, and it's Chandra in the yellow and Alma in the purple. There's a lot going on. As Eric already pointed out, NASA ended the Cycle 1, the previous false start, let's call it, of Cycle 1 a few years ago, a couple of weeks before the proposal deadline. What we learned from that experience was that as a community, we're probably not as ready as we need to be. That most of the proposers would have been scrambling to get their programs prepared to meet the full specifications that are necessary in the scheduling constraints and the guide star checks to be ready to be placed on the long-range scheduling plan and upon submission. So our whole goal this time around is to make sure the word is out and that everyone is fully cognizant and aware that you need to start your proposals early. And if you're planning to do coordinated efforts with other observatories, you have to really be cognizant of what's going on and when. So where do you find information on the call for proposals? So it hasn't yet been released, but when it does, the easiest place to probably locate it is starting with the JWST website at Space Telescope, stsci.edu. The URL is at the top of the page. And then going down to the box highlighted in blue, call for proposals, and its related policy. Another place you can start is in the James Webb user documentation, which we formally call JDocs. It has its own URL, which you can see there highlighted near the top of the page. But if you go to the sidebar on the left, where it points out the Cycle 1 proposal opportunities, you go through there, and then you'll see the release of the call itself. So some highlights. We anticipate having somewhere between 1,000 and 1,600 proposals, of which something like 300 would be awarded. This will be going to 6,000 hours of observing time. This includes a bit of about 2,000 hours of oversubscriptions so that we make sure that the schedule is highly efficient. The time breakdown per science size category is listed over there, something like 3,500 hours to small programs. Those are programs totaling less than 25 hours. 1,500 hours for medium programs, 25 to 75 hours, and then 1,000 hours to roughly be awarded to large programs above 75 hours. There will also be an opportunity to make use of archival data that will be available through the archival research program, or archival research proposals. And these will allow you to analyze the expected data sets or do theoretical research that has a lasting benefit to JWST. As Jane already pointed out, the ERS programs will have or are awarded nearly 500 hours of observing time, and they will have data available to be analyzed in that first cycle. A large number of GTOs have voluntarily made their data non-proprietary or without an exclusive access period. You can find those on the website with archival research stamped next to them, so they're pretty easy to find. So the way that we typically evaluate proposals, and I think that part of this got cut off at the top, I didn't realize, is by size category. So they're broken down programmatically by size into small, medium, and large, and for the archival set, something that's somewhat equivalent, regular, and legacy. And then there are a large number of options and scientific opportunities, which we highly suggest you look at and look to take advantage of. I won't go into depth about any one of these, other than to say that all these categories have been chosen such that they must meet some scientific requirement. It's not the case that you can expect to take a large program which would be somewhat expensive and hard to get through a time allocation process and break it up into smaller chunks and expect to have that go through. The science needs to motivate the size of the request and the type of request that's there. So there are also long-term proposal opportunities, but those should really be used for things that necessitate having some temporal coverage, like for proper motion studies or for studies of objects, transient objects that need templates after those transients have been discovered and measured. Those sort of things are what that category is intended for, and the other categories have been structured in a very similar way. You need to meet those science requirements and motivations to apply for those categories. So as you may have heard at the NASA Town Hall this morning, we are also an observatory that will be doing a dual anonymous review. What that means is that this is true for both JWST and HST, and proposers must submit their proposals to be anonymous, following the guidelines that we provide in the call. We strongly believe that proposers can provide the information that's relevant to the science that needs to be done without, to adequately allow the TAC to evaluate the scientific merit of what's proposed. Reviewers are going to be tasked with doing exactly that, looking at only the scientific merit and not the team composition, its leadership, or its past experience. And the whole process should go well, I hope. It is firmly the case that JWST opportunities should be open to any investigator who presents a highly compelling scientific case, and those resources must also be used responsibly. There will be an opportunity for evaluating team expertise and background, but that will come after the scientific ranking, and largely most of the recommendations have been constructed. So my final slide is, here's the actual timeline written in text form. The other things of note are that in October we expect the process for budgets to be to begin, where proposals are due at that time, October 22nd. Those notifications will come out in 2021, early 2021. We see that the scheduled launch is in March of that year, and that science will hopefully commence 6 months shortly after. That's what I have to close.
All right, thank you, Lou. All right, so in this part of the presentation, I will provide you with an update on the tools and the infrastructure that exist at or that's been developed by Space Telescope to help you maximize the science of your JWST proposals. That is our general role and goal, is to, while we have a very capable observatory, we're trying to create tools and functionality that will optimize the science that you're proposing. So, as other speakers have noted, of course, we had the delay in the last cycle 1 call for proposals, and that gave us the opportunity to ask you as a community for feedback about what worked and what did not work, and we had time in between then and now to improve the tools and the infrastructure. So hopefully we could fix some of the issues that were noted back then. And so in the surveys that we conducted and the feedback we got, we identified a number of lessons learned. As Lou pointed out as well, one lesson was that it's a new observatory. There are many things to learn about it. So start your work on your proposals early. We also found that many folks had trouble identifying the training resources and documentation that they needed. So we had to make that clearer, where to find things. We, as part of that as well, we discovered that it was important to create training resources that could reach a larger audience. We also got feedback that we needed to create tools to improve the capability of the community to more easily estimate the performance of the observatory for simple cases, and generally improve usability and stability of our many tools. So I'll go through some of these to provide you some highlights. I would like to point you to the link above here. So this is within the JWST documentation system. There's a very handy getting started guide. And so if you are just starting to think about JWST proposals and you haven't thought about it before, start there and it will guide you through the things you need to know and provide you with links where you need to go. First of all, of course, know the deadline. It's May 1st, 2020. That's most important, perhaps. For news, follow us on JWST Observer on Twitter or Facebook for the latest news. We also provide news about the ground system and science of JWST on the JWST website, and so you can go there to look at news for that. And we also round up those news items every 2 months and send it out in our email exploder, and you can sign up for that on MyST on Space Telescope. And become familiar with JWST capabilities, terminology, and documentation. Determine if your targets can be observed. It means check duplication and visibility. Use the exposure time calculator to determine observing parameters, and prepare your proposal using the astronomer's proposal tool. And then, of course, you have to write your science proposal text and submit that. Here's the schedule for the release of the core proposal tools. So that includes APT and ETC. There's been a lot of work ongoing in the latest few months in updating APT to give you the best possible timing model. So this is the model that estimates your observing time, including overheads. So that work means that there will be a release of APT on January 21st with a lot of functionality and a lot in there, but not quite all of it. What that means, though, is that you shouldn't hesitate starting to work on your proposals in APT. There will be another release in early March with some sort of last-minute updates, and this is the version that you should use for your final proposal submission. But again, that doesn't mean you shouldn't start with your proposals before that. You can easily work on your proposals and then do a final submission with the last APT version, the 2020.2. Similarly, there's some last-minute updates to the exposure time calculator for the sensitivities, in particular related to cosmic ray, the cosmic ray model, as well as the thermal background model. And so that means that there will be a final release of the ETC a few days after the call for proposals has come out on January 27th. All right. So in response to the feedback from the community about being easier to estimate performance of the observatory, we did create this tool here called the JWST Interactive Sensitivity Tool, or JWST, and you can find it on this URL up there, jwst.stsci.edu. What this tool enables is that without having to fill out all the ETC forms, you can simply use the sliders on the left to set a certain brightness for a point source as well as an exposure time, and this will immediately and interactively yield your signal to noise ratio as a function of wavelength, and then you can choose as well all the various observing modes. So we hope that's going to be a help for folks to get started. There's also been a lot of work in rewriting the planning tool for the multi-object spectroscopy with NearSpec. That was that tool was tricky to use in the past call for proposals, and so a lot of improvements have been made to that, and we hope it makes it easier to plan NearSpec observations. This will be part of the January release of APT. Documentation has been approved. In particular, one of the pieces of feedback that we got was that it was hard to know how to navigate through the documentation, and in particular whether you had found all the pertinent information. And so we've added on the left-hand side the sidebar, which is essentially works as a table of contents. And so we hope we find that useful. There's also a lot of new video tutorials available on YouTube here, and so this is on the JWST Observer channel. And so these also videos that are intended to help you get started. And so these are short 5-10 minute training videos for use of APT and ETC and other tools. So the final thing that was noted in the feedback that I want to highlight is that we had this need to train more people, and there's a limitation for how many workshops that we can run from Space Telescope. We run a number of workshops for training people in proposal planning, and we reach 50 people maybe for the workshop, but we know we have thousands of potential proposers. And so there was this concept coming up about that tries to address this by adapting a train-the-trainer model. It basically means that if we train folks from the community to a higher degree of detail than we would normally do in a workshop, so that they can go out into the local communities and run their own JWST workshops, we're able to reach many more people. And Katie is going to talk about that after me, so I'm not going to go into that in too much detail. There are a number of events here at the AAS, and some of them we've already had. We did run a JWST workshop on the first day on January 3rd, so that's passed. I do want to point out there's a number of items in the future that you can go to. So tomorrow and the day after tomorrow, there's a number of topical events, open house sessions that are 2 hours long. The first one on Monday is focused on GRISM observations, and the one on Tuesday is focused on NearSpec multi-object spectroscopy observations. And so if you're interested in using those modes, I highly recommend that you try and go to those open house sessions. Of course, we have their booths as well as the NASA booth, and there's the STSCI booth. Just wanted to point out, if you have questions about JWST project status, please go to the NASA booth. Ask your questions there. If you have questions about proposal planning, if you want to try the JWST virtual reality experience, and if you want to pick up a copy of the Pocket Guide, if you don't pick it up on one of the chairs here, you can go to the Space Telescope booth, and we'll help you with that. I also want to point out that there is a user committee for James Webb, and you can see the member list here. The role of the JWST Users Committee is to advise STSCI and NASA of how to optimize the science that we do with James Webb and that the community can do with James Webb. So this is really your conduit for providing feedback outside of when we're actually running a survey. So if you have any comments, anything you want to note, you can send email to the email address there below at jstock.stsci.edu. And they will make sure to take that into account and bring that further to STSCI and to NASA. All right, my last slide here is that what happens after the Cycle 1 deadline. We have spent a lot of effort, a lot of time creating these tools for proposal planning and to help you with that process. But of course, after the deadline, we have to switch gears and think about data analysis. And so there's effort right now at Space Telescope and elsewhere to create the tools that you need for that. And the pipeline, for example, has been developed for a long time. I want to point out that the Director's Discretionary Early Release Science Program, which has been selected, one of the purposes of that was that to have teams from the community committing to deliver both data and tools in time for use with cycle 2 proposals. And so you should expect to hear more about that process and about what those teams might deliver to the community. We will also be developing programs for training in data analysis, and so this includes both training and use of the data pipeline, but also in use of post-pipeline data analysis tools. Those are under development and at the moment are based on in Python on an AstroPy. There will be developed a number of science use cases in form of Jupyter notebooks that you can use as examples of how to use these data analysis tools. And we will also make sure that there are more just-in-time resources for self-teaching, in particular during the commissioning time when a lot of folks from Space Telescope and from NASA are very busy. So that should not preclude you from learning how to, or preparing for JWST data analysis. That might be your most busy time in doing that. And so since the current development for data analysis is very active, your feedback is very welcome. It's a good time to provide feedback for that. And so with that, I will hand the podium to Katie, who will talk about the JWST Masterclass workshops. Thank you.
Hi, everyone. I'm Katie Elatello. I'm in the Science Mission Office at Space Telescope, and I am the chair of the of the organizing committee for the JWST Masterclass. Just as a graphical representation of the question, why do you use a train the trainers model? If Space Telescope, represented here by a blue dot called trainer, was the person who was training somebody, let's say that they could train 6 people. That's wonderful. Obviously, we hope we can train more than 6 people, but go with me here. That 6 people, when we do another training, we train another 6 people. It's 12 people who know it. Then we do another training, we train another 6 people. We now have 18 people, but we ourselves have now put effort into 3 different trainings. But let's say that the level of knowledge we require a person to have such that they can do something is not quite as big as, again, these small blue circles. Maybe they're a little bit smaller. For instance, if you're trying to propose for JWST. So what happens if instead we recruit those 6 people to come, we train those 6 people, and each one of those 6 people trains another 6 people? That means that we have basically been able to take our 1 training session and train 42 people. And then if we do 2, we've trained 84 people. So that is actually the model which we're using to attempt to reach as much of the community as possible. And again, this is quite simplified, but that also means we can reach places that are much more remote, because it's not us trying to train 6 people and then go to another place and train another 6 people. We can train a lot more. So we did this. Specifically, what I'd like to do is, I can see a couple people still in the audience who actually are on this list. So could people who were part of the masterclass participant list and their team members stand up for us, please? Now I'd like everyone to give these folks a round of applause. So our first group of 28 masterclass participants came to Space Telescope for a week. Not only did they come, they proposed by telling us how they were going to do local workshops to reach out to their communities. That's how they got accepted into our program. These 28 participants did homework, hours and hours and hours of homework for us to get themselves up to speed so that they could come to Space Telescope for an intensive week of training where they learned a huge amount about the other instrument modes, etc. These folks came from around the world and are running workshops around the world. Each one of these dots represents one of the places that these trainers are training. And as you can see, these dots are not concentrated in what we could call research nodes. They really do span the entire United States and, in fact, the world. On top of this, ESA is actually running a second masterclass based on ours and is reaching out to a lot of people in Europe. And between the ESA and the Space Telescope JWST masterclasses, we're actually going to have workshops run on all 5 of the continents because unfortunately Antarctica on this did not get their act together. So what we're trying to do here is we're trying to make JWST proposing as accessible to everyone as we possibly can. So if you saw a dot that was near you, or you saw a name of somebody at your institution or at a neighboring institution, you can ask yourself what you're going to get from those community workshops. So you're going to get familiarized and started with the technical work for your observing proposal. As Lou pointed out, one of the lessons we have learned is that people were not getting through these cumbersome, high learning curve tools early enough that they would be able to do their proposing. And so the workshops are also spaced out such that you will be able to work with your community with, again, one of these organizers to start your proposals early enough you can break these learning curves. They're going to familiarize you with the resources, JDocs, the JWST User Observer YouTube page, the help desk, and introduce you to the ETC and the APT. So again, you're starting to get your familiarity. But the thing that's really fun about this is that we did not assume at Space Telescope we knew what each community needed. So we actually let people decide what else they wanted to bring to their communities. So your workshop organizers don't have a standard plan. There are some who are going to do certain kinds of instrument modes and some who are going to do different ones, which means you can reach out to them and find out what they have planned for you. And finally, these community workshop organizers are enablers for you. They're enabling you to do the best proposal you possibly can. The ultimate authority for JWST-related questions remains Space Telescope. It is possible that they are not going to be able to answer a question for you. That is okay. They know exactly how to get in touch with the people who are going to be able to answer those questions. Finally, the last thing we promised the community is that, unfortunately, as much as we would love to have every single person who is great and wants to run a community workshop come to Space Telescope, there's only so much time in a day and only so much that our wonderful, brilliant folks can actually help do. So we've actually also created a workshop in a box. That is, if you want to run a local workshop in your community, Space Telescope has put together a box where you get all of the JWST masterclass training materials, which includes how to get started, how to get your computer ready to run the tools, the homework assignments that our participants did, as well as the answer keys for those homework assignments, all of the overview talks, and finally the hands-on material of the different modes that they learned. And the workshop box can be downloaded at the website from the previous page, which also lists where all of the proposals are. And from there, that's all I have to say. There are a lot of ways you will be able to work on your JWST proposals. And what I would have to say is propose early and propose often.
All right, thank you so much. We now have the opportunity to ask questions to all the speakers. If you have any, you can step up to the microphone or...
Yeah, Dan Falk, freelance science writer. Can you hear me? Okay. This was great. My question is about the relationship between JWST and the public. And earlier today, there was a session celebrating 30 years of Hubble. And of course, people have a very sort of emotional attachment to the pictures from the Hubble Space Telescope. Now, in this case, we're talking about infrared, or mostly infrared images. So I know this calls for speculation, but what do you think, will it be possible to capture the public imagination in the same way that Hubble did so spectacularly?
Go ahead, Eric.
I'll take this. Are these mics on here?
Yeah, this should be.
Okay. So Webb was designed from the start to have the same visual acuity as a Hubble image. So they will be just as sharp or clear a picture. And we will use several filters to, again, make false color images, but coding them the same way you code Hubble, where redder things are cooler. So to the untrained eye, they should look the same, but of course they'll be exploring different physics because they're looking at a different part of the spectrum. And so in the best of all possible worlds, you have a Hubble image and a Webb image, both just as sharp, showing you different parts of physics going on with that particular object.
All right. Are there other questions to any of our speakers? Go ahead.
Thanks so much for the talks. Sorry for being practical. So how will the funding situation look like for JWST, given how will this funding situation look like for JWST, given the, I think in 2020 August, cycle 1 proposals will be, some of the proposals will be approved, but the data will come only late 2021, right? So given that gap, how will the funding situation look like? Thanks.
So on the global program funding, that looks good. We have the funding that we've asked for in the replan, which includes operational funding, which has the GEO funding in it. So I don't know if there's any further thing you want to say
for
about
individual
GEO
programs, approved programs.
So for approved, I don't know, is this?
It should be on.
It's on.
Okay. For approved programs, so as you saw, you will get your notification of how much of a budget you will receive once you start receiving your data somewhere around the 1st of June of 2020, sorry, July. What did I say? June, July, January. It's 2 o'clock my time. Give me January of 2021. That gives us a little, it gives you as a awarded PI time to figure out how you're going to make use of that money and perhaps get geared up, get your team ready, et cetera. But you're absolutely right. We don't expect that you will receive your funding until the first data arrive.
Okay, thanks.
All right. Any other questions? Going once, going twice. All right. Then I say thank you so much for everybody coming and for sticking around. And we'll be looking very much forward to seeing all your amazing proposals.
There are no more excuses.
Yeah, so thank you all the speakers.